Alright, what's up guys? This is Probability by Pitman, Chapter 2, review section, problem number 14. Okay, hey, if Ted and Jim are among 10 people arranged randomly in a line, what is the chance that they stand next to each other? Okay, so the way to approach this problem is let's treat Ted and Jim as if they are one person. If you do that, then there are only 9 people, because we have one less person since Ted and Jim are counted as one person in the 10 people. So the number of unique ways to arrange 9 people is 9 factorial. But we're not done. Ted and Jim could be in this orientation or this orientation. You have to pick one of them. Or there are 2 ways for them to be oriented throughout all of these combinations possible. So we'll multiply this whole thing by 2. And then we have to divide by the total number of combinations possible, which is 10 factorial. This includes all combinations, including Ted and Jim next to each other, or Ted and Jim not next to each other. Okay, that's our answer for part A. Part B. What if the 10 people are arranged at random in a circle? Okay, this is a little more interesting because for a line, there are n factorial ways for people to be arranged. In a circle, there are n minus 1 factorial ways for people to be arranged. I was kind of confused about this until I just drew it out. So let's say we have 3 dudes. 1, 2, 3. So that's one way to write it. Another way to write it is 3, 2, 1. So in this one we have 1 to 2, 2 to 3, and then 3 to 1. In this one we have 1 to 3, 3 to 2, and then 2 to 1. Let's try another combo, Let's try 2, 3, 1. You'll notice that we still have, no matter what other combo you do from this point onwards, you just have 1 to 2, 2 to 3, 3 to 1. You end up with a repeat of the first one. So basically, there's always one less, n minus 1 factorial less combos, because you'll end up with a repeat, because the last one can still be next to the first one. It's like saying the last person in the line is next to the first person in the line, so it allows for these repeats that normally couldn't happen in a line. So the total number of combinations possible is n minus 1 factorial. So now knowing this, let us calculate this out. So once again, we'll treat Ted and Jim as if they're one person. So if we have 10 total people, that means we have 9 people now in this scenario where Ted and Jim are one person. So that means using our formula, or what we just figured out, there are 8 factorial ways to arrange these 9 pseudo people. And once again, Ted and Jim can be arranged in 2 ways, TJ or JT. So we'll multiply 8 factorial by 2. So these are the total ways in a circle you can arrange these 10 people, so Ted and Jim are next to each other. Now we divide by the total way to arrange 10 people in a circle, which using our formula is simply 9 factorial. Actually we can simplify these. These are pretty easy. So 2 times 9 factorial over 10 factorial. So we'll know that the entire 9 factorial cancels out with most of 10 factorial, except the 10 remains. So it's just 2 over 10. And then for this one, the entire 8 factorial cancels out, and most of 9 factorial will just cancel out, but the 9 remains. So it's just 2 over 9. And voila, that's our answer for part A. And part B. Oh man. I'm so tired. Okay, C. Okay. Generalize to find the chance of k particular people ending up all together if n people are arranged at random in a line or a circle. Okay. So p k people together line. We can just use what we just did. So the number of ways to okay, first let's just do it in the same order we did before. So we'll treat those K people as one entity, as one person, as one unit, as one love, as one sorry, okay, that was okay, I'm sorry. We'll treat them as one person. Okay, cool. So if we treat them as one person, that means our total number of people is simply n minus k. So for example, if we have, or sorry, n plus 1 minus k. So for example, if we have 10 people and we have 3 people we want sitting next to each other, or arranged next to each other, that means in this scenario, we have 10 plus 1 minus 3, which is equal to 8, because now 2 of these people are counted together. So our formula is n plus 1 minus k factorial. That's the number of ways to arrange all the people when you combine the people that we want sitting together into one pseudo person. Alright, cool. Then once again, we have to multiply by the factor of how many times, how many ways these k people can be arranged. And that's pretty simple. That's just k factorial, yo. Okay, pretty easy. Then we just divide by n factorial because that's the total number of ways to arrange people, regardless if our k people are sitting together. Alright, so that's the answer for generalizing k people sitting together in a line or standing together in a line. Who gives a fuck? Okay, k people together in a circle. Ooh, ooh, circle better than line. Ooh, yeah, okay. So it's literally the exact same thing. We do this same thing of n plus 1 minus k factorial, except remember, for a circle, there are n minus 1 ways to arrange them. So, you'll notice that that means we can simply subtract k in itself. We don't need it, the plus 1 and the minus 1 cancel out, so we can just do n minus k. The plus 1 isn't necessary when we're only dealing with n minus 1 instead of n. That's n minus 1 factorial. And then once again, we have to multiply by a factor. This part doesn't change. We use k factorial once more because there are k factorial ways to arrange k people. Once again, if we have a, b, c, you can arrange c, b, a, or b, a, c. Or any other order you deem appropriate. Maybe you like spelling words, cab, yeah, or blood alcohol content, you know? Woo. Okay, so there's 6 ways to do that if you have 3 letters. So that's k factorial. So then you divide by the total number of ways to arrange people, which once again is just n minus 1 factorial. There we have it. There's our answer. That's the number of ways to arrange k people together in a circle, generalizing for k people together with n total people. Alright, cool. Thanks for watching, and I hope